Hello friends, welcome to Hydraulics and Hydraulic Machines class. In today's lecture, we focus on the effect of acceleration of the piston and the friction loss in suction pipe and delivery pipe on the pressure head. So initially we started with suction head, delivery head. The pressure in the cylinder during suction stroke is the suction head. The pressure in the cylinder during delivery stroke is the delivery head. This is what first we told. Accordingly, we have drawn the indicator diagram. Accordingly, we calculated the work done and all. Next, we debated on the effect of acceleration of piston on the pressure head. So because of the acceleration pressure head, the pressure head during suction stroke had changed. Similarly, the pressure head during delivery stroke also changed. So those effects we have studied. And accordingly, we have drawn the indicator diagrams. Then next, we have studied about the friction loss in suction pipe and its effect on the pressure head during suction stroke and during delivery stroke. And we have shown that individually the friction loss effect on the indicator diagram. So we have done first is general without having anything, just suction head, delivery head. That is the first case. Then we have superimposed the acceleration pressure head. That is number two. Then third, on the first one, we superimposed friction loss. So 1 plus 3. So that is third thing. Now the final thing is, so now we are finalizing about if there are, because why if it will be, there will be acceleration effect. There will be friction loss. So if you consider both the acceleration pressure head effect, both the friction loss effect, then how the pressure head is going to change. Then how the indicator diagram changes. Then how to calculate the work done considering all these things. This is today's focus. Today's focus is not just for this lecture only. The next lecture is what is the maximum speed of reciprocating pump. If you want to understand that topic, this becomes the prelude for that. So that is the importance of this chapter, and very simple, and it's very easy because everything we have studied, now we are bringing it at one place so that we really, what you call it as, represent the whole effect of acceleration and friction loss at any instant of flow. on indicator diagram. First, suction head is equal to HS. Delivery head is equal to HD. Acceleration pressure head we represent by HA is equal to L by G, A by A, omega square or cos theta. Friction loss HF is equal to L by G, basically FL by 2GD, right, into A by A omega R whole square. This is the general thing. From here I will start. Let us take suction stroke. Suction stroke. If I take suction stroke, basically if you take generally for any angle of crank, for any angle of crank, theta, the equation is the pressure head is equal to HS plus HAS plus HFS. This is general, total. Now let us take one after the other. At the beginning, theta is equal to 0 degrees. Therefore, HAS is equal to 0 because it is cos 0. Whereas HFS is equal to FLS by 2G ds into A by AS omega R whole square. This is equal to 0 at the beginning, whereas HAS is equal to LS by G, A by AS, omega square R cos 0 degrees. It is equal to LS by G, A by AS, omega square R cos 0. Basically, it is 1. So, this is this. So, final conclusion is the suction head is equal to, what is this? HS, right? Plus what? Plus LS by G, A by AS, omega square R plus 0. So this is total suction head. So therefore, pressure head in the cylinder, during suction stroke at the beginning that is theta is equal to 0 degrees is Hs plus HAS, as HFS is equal to 0, which is equal to Hs plus Ls by G, A by AS, omega square R S. This is negative pressure. This is below atmospheric pressure. Therefore, if you want the absolute pressure head is equal to H atmosphere minus of Hs plus HAS. This is the first thing. Now similarly, I will cut short at the middle of the suction stroke. At the middle of suction stroke, theta is equal to 90 degrees. When theta is equal to 90 degrees, HAS is equal to 0, as cos 90 is equal to 0, whereas HFS is equal to FLS by 2GDS into omega square R whole square. Sorry, not omega square, I'm sorry, just omega R whole square. Perfect. Right. Therefore, pressure head is equal to Hs plus HFS, as HAS is equal to 0. This is also negative pressure head. This is also below atmospheric pressure head, and this is below atmospheric pressure head. And if you want to write what is the absolute pressure head, it is equal to H atmosphere minus Hs plus HFS. That's the thing. Now I will go to the end of the suction stroke. At the end of the suction stroke, theta is equal to 180. Therefore, cos 180 is equal to minus 1. Therefore, HAS is equal to minus Ls by G, A by AS, omega square R. HFS is equal to 0. Therefore, pressure head is equal to Hs minus HAS, as HFS is equal to 0. That means absolute pressure head is equal to H atmosphere minus Hs minus HAS. And we know HAS is equal to minus LS by G A by AS omega square. So this is similarly, if I go to delivery stroke, at the beginning, if you take it, theta is equal to 0, therefore cos 0 is equal to 1 and sin 0 is equal to 0. Therefore, HAD is equal to LD by G A by AD omega square R. HFT is equal to 0. You know general equations for this are HAD is equal to LD by G A by AD omega square R cos theta. Similarly, HFD is equal to FL by 2GDD into FLD by 2GDD into A by AD omega or sin theta whole square. This is the general. So now accordingly put it. Therefore, pressure head is equal to HD basically plus HAD. This is above atmospheric pressure. Whereas at the middle of delivery stroke, theta is equal to 90. Therefore, cos 90 is equal to 0, whereas sin 90 is equal to 1. Therefore, HAD is equal to 0 and HFD is equal to FLD by 2G dd into A by AD omega R whole square. Therefore, total pressure head is equal to HD plus HFD above atmospheric pressure. Then at the end of the delivery stroke, theta is equal to 180 degrees. Cos 180 degrees is equal to minus 1. Sin 180 degrees is equal to 0. Therefore, HAD is equal to minus LD by G A by AD omega square R. HFD is equal to 0. Therefore, pressure head is equal to HD minus HAD above atmospheric pressure head. So if I conclude the whole thing, if I write here the suction stroke, similarly delivery stroke. So we are studying about pressure head in cylinder, right? Now what we are doing, theta is equal to 0, that is beginning. So total head is equal to here Hs basically plus HAS plus 0 friction. So here it is at the beginning, if you take it, HD plus HAD plus friction is 0. At theta is equal to 90 degrees, it is Hs plus, this is HAS is 0 plus HFS. Here it is equal to HD basically. Here this is 0, this is HFD. When theta is equal to 180 degrees, it is HS minus HAS 0, HD minus HAD 0. So this is the thing. And what is the variation actually? Why? Because the general equation for HA is L by G, A by A, omega R cos theta, omega square R. This is the thing. Whereas HF is equal to FL by 2 GD into A by A omega R sin theta whole square. So this is the thing. Accordingly, the theta value, if you substitute, you get these things. This we will stop here. Now I will draw the indicator diagram. Please closely follow. So this is stroke length L, and this is pressure head, right? Now already I told keep somewhere H atmosphere. This is the thing. Then now I will draw. Just see how I am drawing. So this part is HS. This is HD. This is the ideal indicator diagram. This is below atmospheric pressure. This is above. Then what we have done, we have superimposed the acceleration pressure head. This is how the acceleration pressure head modifies the indicator diagram. If I call initial thing as A, B, C, D, of course, E, F, general. Then what I am doing, this is A dash, B dash, C dash, D dash. But the area of the indicator diagram ABCD and A dash B dash both are same. Next, I superimpose now actually on this the basically what I call it as the friction. This is how it is. This is right. Now, if you see the final indicator diagram, if I write it as it is G H. Similarly, it is I basically J. Right? If I take it now, you know this part is HAD. Similarly, this part is HAS. Same is the case. So if you want to write A, for example, AE is equal to HS, then A dash is equal to HAS. Then basically, if I take perpendicular to this perpendicular, basically that is what I want actually, right? This is, I write it as I because that is what I want. This H G dash HG dash is equal to HFS. You understood? Similarly, BB dash is equal to HAS. Okay. So this completes. Here, let us take it. TE is equal to HD. And similarly, CC dash is equal to HAD. Similarly, D dash is also equal to HAD. Then I dash J is equal to what it is HFD because the perpendicular length, height, right? All that are here. Now you see. Now from this what I want, the calculate the work done. So for that work done, what I am doing is first actually now I am calculating what is the area of the indicator diagram. The area of indicator diagram. What is the area of the indicator diagram? First, if I take it actually, it is A dash, right? H, okay, B dash, C dash, J, D dash. So this is a rectangle like. This is first thing plus parabolas. What is that parabolas actually? Area of parabola A dash G B dash. This is 1 plus area of parabola C dash I d dash. If you take it, this is only, it is nothing but finally if you take it, the area is same L into HS plus Y capital HS plus HD, because one side it is higher, one side it is lower. Finally, it is plus area of this parabola is 2/3 of this L into that HFS plus 2/3 of L into HFD. So this is the total area, which is equal to L into HS plus HD plus 2/3 HFS plus 2/3 HFD. So what is the effect of acceleration pressure head on the work done? There is no effect of the acceleration pressure head on the work done. The acceleration pressure head is only change in the basically pressures. Then we know that work done is proportional to area of indicator diagram. So therefore, work done is equal to A into area of indicator diagram is LHS plus HD plus 2/3 HFS plus 2/3 HFD. This is the thing where K is equal to W, sorry, gamma AN by 60. Basically, it is for single acting reciprocating pump, and K is equal to 2 gamma AN by 60 for double acting reciprocating pump. So this is concluded here with the work done equation. We have completed the indicator diagram. On the indicator diagram, the effect of acceleration, pressure head, friction loss, and finally, we linked that to derive the equation for the work done. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.